So section 3.2, number 27. We are asked to look at the graphs of two functions. The first one is minus 2x cubed plus 4x squared minus 1, which looks like this. I've already zoomed out. So if I zoom back into the normal, right, it looks like this. And the other one is y is equal to 2x cubed, which looks like that. All right, and we're supposed to zoom out far enough so that we can see, the left and right behavior as the x values get arbitrarily large. So if we do that, this is our function f, our first one. As x goes off to negative infinity, this thing goes off to positive infinity. And as x goes off to positive infinity, this thing goes off to negative infinity. And the important properties here is that our leading coefficient is negative. So our x cubed, well, as x becomes a very large negative number, and negative times a negative times a negative is a negative, times another negative out here is a positive. So the only pieces of information we really need is the fact that this is an odd power, which means that what happens to our x, the sign stays the same. And we have this extra negative, which then flips the sign. So if x is negative, well, there's 3 negatives and 4 negatives multiplied here. So as x becomes a very large negative, this term, our leading term, becomes a very large positive, and so it will blow up to positive infinity. As x becomes an arbitrarily large number, right, this becomes a positive times a positive times a positive. It becomes an extremely large positive number, but this negative makes it an extremely large negative number. So as x becomes arbitrarily large positively, this thing goes off to negative infinity. If we compare that to this base function, this one, well, this is a positive 2. So on the negative side, as x becomes an arbitrarily large negative number, negative times a negative times a negative is a negative, but we don't have this other negative here, right? So it becomes 3 negatives multiplied together. So on the negative side, this thing stays negative. And so as x becomes an arbitrarily large negative, this becomes an extremely large negative number. And so as x goes off to negative infinity, this function goes off to negative infinity. As x goes off to positive infinity, well, there aren't any negatives here, so it's a positive times a positive times a positive, so this thing will go off to positive infinity. So the only pieces of information we need again here is that this is an odd number, which means we have an odd number of x's, which means that on the positive side, it will go off to either positive or negative infinity depending upon its coefficient. Since it's positive, it will go off to positive. And as x gets negative, well, an odd number of negatives is a negative, and this is a positive, so a positive times a negative is a negative, so it stays negative. So the difference is that this function has a negative in front, essentially flipping the sign of our leading coefficient, and this one does not. So I guess the explanation is our leading coefficient is a negative, which flips the direction, and since it's an odd, that means as x goes negative, the function goes positive, and x goes positive, the function goes negative. And this one, it doesn't. All right?